Hello everyone. So in this session, we are just going to discuss about the memory system and hierarchy. How this memory system is organized, what are the different levels of memory, why we offer memory at different levels, what is the hierarchy to be followed, and different classification of the memory, and salient characteristics of the memory. So like this, we will be discussing about various concepts related to memory. To start with, we will just see how the memory is going to be categorized. Maybe you can just have a look on this diagram. Okay, let me just so in this memory system, we have the CPU, and inside the CPU we also have some basic hardware that can store the data items. That is what we call as registers. So this is going to be the smaller level of memory, which is very closer to the CPU. Okay. After this, then when we come to the next level, we have the concept of cache memory, and this cache memory can be made available in three levels: level 1, level 2, level 3 cache. And some cases this cache memory can also be framed on the chip of the CPU. Then it is going to be called as on chip cache, otherwise it is going to be called as off chip cache. So if you just consider this, the cache memory, it is going to be called as a frequently accessed memory. So all the informations which are going to be frequently accessed are going to be kept in this memory, and this memory itself is available in three levels. So the CPU will first look for the information first in the level 1 cache. If it is found, it is going to be called as a hit. If it is not found, it is referred as a miss. So it will go to the next level, and again it will continue the process till it identifies that particular item. Then the next level of memory is called as main memory. After this cache memory, we have the main memory. So these two memories are going to be directly accessed by the CPU, and these are just available only as a temporary storage. That means if the power is going to be switched off, the content of these memories are going to be lost. So only for temporary purpose we will be storing, and whatever that is available in this cache memory or in this memory is going to be lost when the power is off. So it is referred as a temporary storage memory, and these are the two memories in which the CPU can have direct access. Coming to this main memory, this main memory can be realized with the concept of physical memory, which is actually available in the form of the chip. And also, we will introduce a concept of virtual memory, and this will be discussed in detail in the later classes. But now, this main memory can be identified either as a physical memory or as a virtual memory. So, all this comes under temporary storage. Then, the next level of the memory is going to be called as secondary storage, and here we have all the memories available in this levels are going to support permanent storage. Whereas in the previous two levels, it's going to be temporary storage, and these temporary storage memories are going to be directly accessed by the CPU. Whereas here, it is going to be permanent storage, and as far as the operating system is concerned, it will help the CPU, and it will assist the operating system will assist the CPU to access the information available in the secondary storage. So some of the secondary storage devices are identified here as ROM, okay, read-only memory, and that is very much well known to store this operating system, basic input output system, power on self test routines. Like that, the important driver routines and other operating system related softwares will be made available in ROM. And we can also have some removable drives in which we will be having some storage unit, and we can access that removable that storage devices using this removable drives. And that can also be a network internet storage. Okay, network, it is available in the form of ICs, and we can also have hard drive. So these are the various type of storage structures, mm, that can be provided at the secondary storage level. Okay, then the last level of the memory, the next level is going to be the input output devices, which are going to have some buffer mechanisms, and also can have their own storage components, where these keyboard, the mouse, the removable media, the scanner, the camera, the video devices, and the remote source or other source, these sources can receive the data from the user, and they can have it in some temporary buffer sort of structures, and then it will transfer the content to the secondary storage, and from the secondary storage it will be moved to the main memory by the loader available in the operating system. And then if they are going to be frequently referred, those items alone can be brought to the cache to the next level, and then it will reach the CPU. This is going to be the hierarchy of access across the different levels. the same levels, it can be identified in this diagram here in a different way. So we have the registers and then cache and L1 cache, L2 cache, which is made up of a static RAM, and then we have the concept of main memory, which will be comprised of dynamic random access memory storage devices, and then we have some local secondary storage, which are otherwise referred as a local disk, and we can also go for the remote storage like cloud systems or tapes or distributed file systems and web servers. So these are going to be the different levels, and these levels are numbered as L0, L1, L2, L3, L4, and L5. And if we just observe these levels, what are the features available in these levels? If we just go away from the CPU, as we keep increasing the levels, the size of the memory is going to be increased. So the first point to be observed is the size of the memory is going to be bigger as we approach away from the CPU. Okay. Then slow. Okay, as we go away from the CPU, the speed of access will be very slow. That means if the CPU is going to access something in the registers, it will be high speed. Whereas if it is going to refer from the secondary storage, or if it is going to be referred at the highest levels, obviously it will take too much of time. So it is going to be the speed is going to be very slow when I go away from the CPU. Of course, the size will be higher. Okay. And apart from this, we also have one more parameters to be compared, that is called cost. Okay, as we just go nearer to the CPU, the cost will be more. Okay, it is going to be expensive, highly expensive, because it is going to involve so many hardware components. Okay, so as far as the cost is concerned, if we go nearer, it is going to be high. And as far as the speed is concerned, it will take too much. Speed is also going to be high as I go nearer. And as far as size is concerned, it will become high only if I go away from the CPU. So the three important metrics or the parameters that can provide the capability of the memory is the speed, the size, okay, and then the cost. So the speed, size, and cost, they are interrelated in this way. So as far as this arrow is concerned, it is related to the cost, the speed and the size. As we go away, the size is also more, and speed is also going to be slow. And whereas if I just go nearer, the size will be small and it will be costlier. Okay. So this explains you how the different levels of memory is going to vary by itself in terms of cost, size, and speed. This block diagram explains how the connection is going to be established across the memory. As we all know, here we have the CPU. Of course, the CPU has to be provided with the information. So we have different types of memory as we discussed. So the one which is going to be inside the CPU is going to be registers, and we have the cache memory here. Always the CPU will interact with the cache memory. If the item is not found, then it will look into the main memory. And if it is there, it can use it directly, and at the same time for future references it will keep it in the cache memory. And if it is not in the main memory, then it has to be brought into the main memory. For that purpose, it has to refer to the secondary memory. The secondary memory are also called as auxiliary memory, and the main memory is going to be called as the prime memory. So in this auxiliary memory, we can have different type of secondary storage devices like magnetic tapes, magnetic disk, like that. We can have any type of IO devices. So this storage devices all will come under the auxiliary memory, and the information available in this secondary storage are going to be transferred to the main memory with the help of the IO processor. So we have a kind of a processor dedicated for IO activity, and in order to make the CPU effective, we just assign the process of transferring the data from the secondary memory to the main memory by the IO processor. And once it got transferred to the main memory, it will be directly supplied to the CPU, or if it is going to be frequently referred, it will also be stored in the cache memory. So this is going to be the access mechanism which is going to be followed by the CPU. Every time it will look into the cache memory for data. If it is available, it will use it. Otherwise, it will refer to the main memory. If it is there in the main memory, it will use it. If it is not there in the memory, it has to be brought from the secondary memory to the main memory with the help of the IO processor. This diagram explains the classification of the memory. So as we all know, based on the levels, we have the registers, okay, the primary memory, the cache memory, and the secondary memory, okay. And the registers, of course, it is going to be the hardware unit, which is of limited in number and limited in size, and it is going to be the smallest memory available, and it is going to be the fastest memory, and it is the costliest one. Okay, then coming to the primary memory, this primary memory can be classified into two types. One is called as RAM, and another one is called as ROM. As the name implies, RAM, it is referring to read and write, okay, random access memory. here it is going to be called as the ROM is called as read-only memory, and this read-only memory is also going to be available in different types. One is called as mask ROM, and then this is called as PROM, which is called as programmable read-only memory, and this is erasable programmable read-only memory. And how we are going to erase? If we are going to use electrical signals for erasing, then it is called as electrically erasable programmable read-only memory. And we also have one read-only memory which is called as a flash ROM. So these are the different types of ROM available under the category read-only. Whereas if we just take read and write memory, or otherwise the random access memory, so here we have again further classified this read-write memory into two categories. As the name implies here, this memory can be used to both read the information and also the write information. Whereas here in this memory we can only read, we cannot write. So if we cannot write, how can we read it? It has to be programmed. So the manufacturer, once they fabricate this IC, they will program it, and after programming you have to use only for read purpose. Okay, now coming to this read and write memory, this read and write memory is called as RAM and ROM. Okay, sorry, read and write memory is going to be classified in two categories based on the type of access it is supporting. One is called as random access memory. Another one is called a sequential access memory. So what do you mean by random access? At random, you can go to any location and then access the content. Whereas sequential access, right from the beginning, from the first track, you have to access the memory. Maybe you can just relate with a real-time example. If you're just going to hear the songs using CDs, so you can play any song at your wish, at your will and wish. So if you're able to play any song, whatever you desire at any time, then it is going to be called as random access. Suppose if you are going to listen to the songs from the cassettes, or audio tapes. So in that case, if you want to play the fifth song, no other go, you have to traverse all the four songs, then only you can reach the fifth song. Either you have to traverse one by one, or you have to fast forward. So this will support only sequential access. Always you have to start from the beginning. Whether you like it or not like it, you have to trace it, and then you reach the location. Whereas in random access, at random you can go to any track, any sector, and play that information available in that. Okay, so this random access memory can still be further classified into static random access and dynamic random access, and this classification is based on the nature of the component which is used to frame these devices. Okay, if you are going to use capacitors, then the capacitors will be charged and discharged. They cannot store the data item for longer period of time, so every time it has to be recharged. So dynamically it's going to change, so we have to refresh it every time. So that is going to be coming under the category dynamic random access. Whereas if some other components like flip-flops are going to be used, the content stored in this RAM is going to be static or fixed, so need not refresh it. So that will come under the category SRAM. Okay. Now coming to the secondary memory, again the secondary memory can be classified into two categories based on the access which we are going to do, whether it is going to permit serial access or it is going to be semi-random. So if you just identify what are the devices which are coming under the category serial access, you can look into this: the magnetic tape, the CCD charge coupled drive, and then the ferrite core. So all these type of storage devices will come under the category serial access under the secondary memory. And then semi-random access, so all the direct access disk, the compact disk, okay, the high definition disk, the digital versatile disk, the floppy disk, all these will come under the category semi-random. Why it is called as semi-random? You cannot directly do access the content directly, you cannot do a random access. At the same time, it is not sequential also, so it is going to fit into the category semi-random. So this diagram explains you the classification of the memory into different categories, where we have the main classification as primary memory, cache memory, and secondary memory. So the primary memory is going to be classified as whether it is going to permit read and write operation or read only. Okay, and those which permits both read and write can be further classified as random access and sequential access. Okay, which is again further classified into static random access and dynamic random access. Whereas if you just take read only memory, it will be classified into different types based on the type of access it is going to permit and how it is going to be erased. Okay, then coming to the secondary memory, it can be serial access or semi-random access. So the serial access will have the magnetic tape, CCD, and ferrite core under this category, whereas all the remaining will come under the semi-random access. So we have just discussed different levels of memory, the hierarchy of memory, how these different levels of memory vary in terms of speed, cost, and uh, uh, size, and we have also discussed the various classification of the memory. Hello everyone. So in this session, we will just continue our discussion of memory system and hierarchy. Already we have discussed how the different levels of memory is going to be organized, what is the need for the different levels, and how this cost, speed, and expense, cost, speed, and the size is going to vary for different levels. Of course, the same thing is repeated here. The CPU registers next level cache memory. Cache itself can be identified in three levels, either as on-chip cache, off-chip cache, and level 1, level 2, level 3 cache. Then comes the main memory. Then comes the secondary memory, which is identified as external memory, which can be leveled as magnetic disk, optical disk, magnetic tape. Okay. Now, if we just consider all the memories which are inside the cabin, then it is going to be called as the internal memory. And these are the memory where the CPU can have direct access. In coming to external memory, they cannot have direct access. Of course, the speed is going to be limited. So this line, I think it represents how these levels are going to relate the important parameters, namely the speed, size, and the cost. So as we approach the lowermost level, the speed is going to increase, and the not only the speed, the speed and cost are going to be directly proportional. So it is going to increase as we move on to the nearest level. Okay. And then if we just compare the size, if we go away from the CPU registers, the size is going to increase in this level. So this explanation already we have discussed in the previous session. Now we will just see the various features of the memory. Okay, how we are going to classify the memories based on some features. So first we will just identify the location of the memory, where actually it is going to be located. By location, what we mean, whether it's internal to the cabin or external to the memory, or it is going to be external memory. So internal means it should be within the cabin. If it is going to be outside the cabin, it is going to be called as external memory. So some of the memories which are outside the external, outside the CPU is going to be disk tape, USB pen drive, hard disk drive, something like that. Okay, all the registers, the cache memory and the main memory will be identified as internal memory, and they are all volatile in nature. What we mean by volatility, if the power is not there, the content will be lost. So this is only coming under the category temporary storage, whereas the remaining memories will have permanent storage, and they are all non-volatile. Okay, then next comes the capacity. So how we are going to rate the size of the based on the storage capacity of the different memories. Again, we can have internal memory capacity and external memory capacity. So external the storage capacity is always measured in terms of byte, whereas internal memory is always measured with words. Okay, so the storage length also can vary. Then coming to the access methods, how we are going to access each memory location. So based on the type of access, we are having different classification. So the first classification is called as direct memory access, where the input and output devices are allowed to directly access the memory. So they will directly access the main memory without the help of the CPU, and this will usually implemented with the help of the DMA controller. Okay, the next access is going to be the sequential access. So in the sequential access, what we have told, the data is going to be stored serially from in the computer memory, and it will be read or location by location. Starting from the initial address, it will start going to read the next location. Like that, it is going to read the information in the memory one by one. Whereas the next method of access is random access. As the name implies, at random we can go switch over to any location, get the information. So need not be traversing start from the beginning. And of course, random access is usually prepared, and only for that reason we have the memory called RAM, which is specifying the type of access it is adopting. Then comes associative access. Here associative access is going to be a special type of memory which always claim to be optimizing the search performance. How it is optimizing the search performance, maybe that concept will be discussed later in the last of this chapter under the topic associative memory. Okay, then based on this access methods, we have these classifications. The next important parameter is the unit of transfer. How the data is going to be transferred across different levels of memory, or what is the unit of transfer which we are going to refer to. Suppose in case if it is going to be internal memory, any data which is going to be transferred across the different levels in the internal memory is going to be identified in terms of word size. Whereas if we take external memory, it is going to be identified in terms of blocks. Okay, so we always have different units of reference pattern. One is called as line, next one we call as a block, and then we call as a page, and then we have the concept of frame. If it is from the secondary memory to the main memory, it will be referred in terms of pages, and from the main memory into the cache memory, it will be in terms of blocks, and within the cache memory we are going to consider it as a lines. So we have different units which are going to be referred in different levels. Obviously, If it is going to be in registers, it will be identified in terms of number of bits. Okay, in cache memory, every single unit is going to be called as a line. In main memory, it is going to be called as a block. And when it comes to secondary memory, it can be referred as a pages, or main memory can also be referred as a frame. Of course, these concepts will be discussed in detail when we are discussing about the memory unit. Okay, here the unit of transfer, it is going to vary for internal memory and external memory, where it is generically classified as either the word size or in terms of block size. Then comes the classification based on the performance. So what are the important factors which are to be considered to measure the performance of the computing system? We have three terminologies, namely the access time, the memory cycle time, and the transfer rate. So what actually we mean by the access time? So if it is going to be random access memory, it represents the total time taken by the memory devices to perform the read operation or the write operation. So usually what we will do, in which location we have to read or in which location we have to write, we will first specify the address. So given the address, it will take some time for us to store the information into the memory or get the information from the memory. So this time interval after placing the address and then getting the operation done, this time interval is going to be referred as the access time. Then comes memory cycle time. So what is memory cycle time? It is a total time required to access the entire memory block. So it is not going to be with respect to a particular word. So how much time it is going to take to transfer the whole block. So whenever the CPU is in need of a particular word, it is not going to read it as a word. Usually it will be done in terms of blocks. So what is the total time taken to get the entire block from the memory? That is going to be considered as the memory cycle time. So usually the memory cycle time will constitute the access time and also the initial and the later overheads. So prior to the read and prior to the write operation, what are the overheads involved? So that also will be accounted for the memory cycle time. Then comes the transfer rate. So what we mean by transfer rate? It is the rate of data the data is transmitted to the memory or from the memory. So the rate at which it is going to be transferred. So within a given unit of time, how much bits of information is going to be read from the memory or how much bits of information is going to be written into the memory, that decides the speed. So the transfer rate is also an important parameter. So whenever we are whenever we are evaluating the performance of a particular memory level, we will be very much keen on the access time, the memory cycle time, and the transfer rate. Then comes a physical type. So what are the physical component which is going to be used to constitute that particular memory? The basic component used to build that memory, that comes under the category physical type. So usually the memory can be made of magnetic materials, or it can be made of semiconductor type, or it can be a combination of magnetic material and optical type, or it can be purely optical. So based on the physical component used to design that memory, we have the classification called as physical type. Next comes the organization. How the physical structure of the memory is going to be organized. So that is also going to come under the category of one classification of the memory feature. And then the last one, which is going to be called as the physical characteristics. So what we actually mean by physical characteristics, it refers to the behavior of the memory. So by behavior, what we are trying to conclude, whether it is going to be volatile in nature or non-volatile in nature. What we mean by volatility and non-volatility, if the power is there, whether the content is going to be retained or the content is going to be lost. So based on that, we have the characteristics volatile and non-volatile, and sometimes we also have some memory which cannot be erased. So whether it is going to support erasing feature or non-erasable. So based on these factors, we have further classifications. So always the permanent memory will come under the category non-volatile. It is a permanent storage memory, and this permanent storage memory is going to be applicable only for the secondary levels of memory, secondary storage devices. All the main memory and the cache memory, they are not going to have, they are going to have the content only in temporary manner. So that will come under the other category, volatile. Okay, now the next thing is classification of the memory. I think we have already discussed in the previous session how the memory is going to be classified. So primary memory or main memory, secondary memory, otherwise called as auxiliary memory, then comes a cache memory, then comes a register. So if you take secondary memory, all the storage devices whatever we are going to use, that will come under the category secondary storage. And the main memory, Again, it is going to be RAM or ROM. There we have random access, and this ROM is also random access, but ROM will support only read, whereas RAM will support both read and read. So this RAM is again classified as static and dynamic, and this ROM, based on the way in which we are going to program that and the way in which we are going to erase the content in that, accordingly we have different classifications, namely programmable read-only memory, electrically programmable read-only memory, electrically erasable programmable read-only memory, and also we have ultraviolet erasable read-only memory. So like this, there are so many classifications which comes under the category of memory. And primary memory and main memory. So the memory which is going to be closer to the CPU is always going to be called as a main memory, and the CPU can access the information only from the main memory, and they are notable for its temporary storage and faster data processing rate, and it is usually referred as volatile memory. And of course they are going to be costlier than the secondary memory, but if you take the size, it is going to be limited. So random access memory, read only memory, already we have discussed a lot. So if you just see the random access memory, it will be available like a chip. So it will be like a kind of an add-on card which can be inserted into the port available in the exterior part of the cabin. Okay, so we can always upgrade the size of the random memory, and more the size of the random memory, that will decide the speed of the processor. So if we have enough space, working space, the swap in swap out time can be minimized, and thereby we will be able to improve the efficiency of the entire system. So we always have provide this RAM as a separate chip, and this can be considered as like a kind of an add-on card which is available in the exterior port. Then this RAM itself can be further classified as static RAM and dynamic RAM. So this is going to be classified based on the type of the component which is used to frame this memory. So in the name dynamic random access memory, the content is going to dynamically change. Why it is dynamically changing? Because it is going to make use of capacitors. Okay, so if capacitors are used, the basic nature of the working principle of the capacitor is it usually charges and then discharges. So when it is going to discharge, the content is going to be lost. So we have to periodically refresh, and then only the memory content will be retained. So here they have told if the power is switched off, the data is going to be lost. And the characteristics of dynamic RAM is it has needs to be continuously refreshed. Only then we will be able to retain the data. And of course, it is lower than the static RAM, and it also holds large amount of data, and it uses the combination of capacitors and transistor as a basic building block for framing this memory. And of course it is less expensive when compared to static RAM, and power consumption also is going to be very less. Now coming to the static RAM, it is the content is the static type of RAM memory is usually built with floppies, flip-flops and other things, and usually the content stored here will be permanent. Okay, the data is lost when the power failure has occurred, but still we need not do any refreshing. So no need to refresh. It is of course faster than the dynamic RAM, and it is also expensive, and it is notable for high power consumption. Most of the characteristics whatever we have seen for DRAM, that is going to conflict here. Okay, it has a longer life and also supports larger size, and usually the static RAM is going to be framed for the cache memory, because we already know cache memory is a high speed memory. Its speed is going to be attained because of the basic component which is used here, and since it is faster than DRAM, this is going to be the best suitable memory that can be used to design a cache memory. So here we tabulate the difference between the static RAM and dynamic RAM. As the name implies, the SRAM stands for static random access and DRAM stands for dynamic random access. Of course, the access time is going to be slow here, whereas it is high here. If the basic component used here is flip-flop, whereas here we use capacitors. Okay, and because it is not using capacitors, it needs no refreshment. Whereas in the capacitors, if capacitors are used, its charge is going to be lost, so we have to keep on periodically refreshing to, so then only the content will be preserved. And usually for framing the cache memory we will be using SRAM, and for designing the main memory we will be using DRAM. And of course the SRAM already we told it is expensive, but DRAM is less expensive when compared to SRAM. It is going to support a class complex structure, whereas here the DRAM structure is going to be very simple. It requires low power consumption, and this requires more power consumption. So whatever we have discussed here, based on that we have some advantages of RAM and disadvantages of RAM. Okay, it's going to be self-explanatory, so we can just go through this and it will be clear to you. Our RAM advantages is faster in nature, less power, and it increases the performance of the system for multitasking, and of course the program is going to be loaded faster and it's suitable for performing read and write operation. Coming to the drawbacks of rom, it is volatile in nature, so it cannot preserve the data. It is expensive than the rom, and it is unreliable when compared to rom, and the size of the ram is of course limited. So due to its volatility nature, it requires electricity to preserve the data, and of course it reduces the speed and overall performance. Hello everyone. So in this session we will just continue our discussion with respect to memory system. In the previous sessions we have classified the memories and we have just seen the hierarchy. Okay, now we will just see what actually we mean by the different types of memories. Here we will discuss read-only memory. So as the name implies, it is meant for read-only purpose. We cannot write anything. So it is a memory device where the storage medium is used to permanently store some information inside the chip, and this information is going to be stored only by the manufacturers and not by the individual users. Okay, so usually this RAM is going to be suggested to store the data that are required to start or boot a computer, because it is going to be a permanent storage. So the driver routines, the booting routines, and all these things will be initialized in the RAM chip. So it is of course going to be a category of non-volatile memory, meaning that even if the power is not there, the content is not going to be erased. Okay, even if the system is shut down, it will remain as such. Now this is going to be the sample chip, how it will look like. So this is going to be the ROM chip where all the startup routines are going to be stored inside. So stored inside, and we will just now see the types of ROM. As already we have discussed, one is called as MROM. It is masked read-only memory. So it is going to be the oldest type of read-only memory, and it can be configured by any integrated circuit manufacturer at the time of manufacturing. So usually it will contain the program or the instructions within the ROM chip, and it cannot be changed by the user. The next one is called as programmable read-only memory. Here of course the memory is going to be programmed by the manufacturer, as we have seen for mass read-only. Here we have the empty PROM chip, and once the user has written the desired content in it, then it is going to be permanently stored and we cannot erase it. So that's what we call as programmable. We can program this read-only memory for our own purpose. And next comes EPROM, which is referring to erasable and programmable. So it is programmable one time, and then you can erase the content if you want to reprogram it. Actually this type of memory, it is also non-volatile, and it holds the data as long as the power supply is there, and it can store the data for the maximum for a period of 10 to 20 years. And if you want to erase any stored data, we can also erase it, and we can also reprogram it with new information we pass on. So for that purpose, for erasing the content, we will just pass on this chip to the ultraviolet light for 40 minutes, so that the data stored in this will be fully lost. And once it is lost, then we can program it again another time by loading the fresh item into that memory. Next comes electrically erasable. Here in the previous case, we have discussed about an ultraviolet erasable, whereas here it is electrically erasable type of memory. Here it is also non-volatile, and the data cannot be erased. Okay, even if the power is off. But if we want to erase it and we want to reprogram it, then we can erase it by means of electrical by applying electrical energy. So the stored data can be erased, and we will not be doing more often, and it can be reprogrammed any number of times. And the data will be erased only one byte at a time. Byte by byte it will be erased. So the content is going to be erased by means of electrical signal, whereas in the previous case the content is going to be erased by exposing the chip to the ultraviolet rays. Then comes a flash RAM. So this is of course people will be used to this. Flash memory is otherwise called as pen type memory or USB. Okay, it is a non-volatile storage memory and can be written in small units called block or sectors. So flash memory is a part of it's going to be a subset of EE programmable ROM read-only memory, and the content of the data cannot be lost when the power source is turned off. It is usually this flash type of memory. It is usually used to transfer the information from one computer to another computer, or from any electronic gadget to the computers. Now I think we have discussed about the various types of ROMs based on the technique in which we are adapting for programming it, and the technique for which we are going to use it for erasing. Then comes advantages of RAM. So as the main point, main important characteristics, it is non-volatile in nature. So the content is not going to be lost even if it is powered off, and it is going to be static in nature, because the content stored is made permanent forever, and it need not be refreshed every time. And so it is easy to test and store large data as compared to random access memory, and by accidentally also we cannot change the content stored in it, and of course it is cheaper than the RAM, and it is of course simple also reliable as compared to RAM, and then it helps to start the computer or the boot the computer by loading the operating systems in the read only memory. So usually this read only memory is going to have some fixed routines which is going to be specifically used, which is going to be generically used for all the computers, and especially this BIOS routine, post power on self test routine, basic input output system routine, and all the booting process will be stored in this read only memory. Coming to the disadvantages of RAM, it cannot be updated because we told it is only read only, we cannot write it, and so it is not possible for us to modify, and if at all we need to modify, we have to erase the entire content and we have to program it, support, provided the RAM has to support that feature. And of course it is slower than the random access memory which is used to store the data, and of course it takes around 40 minutes to destroy the existing data because it is going to do it byte by byte, and it needs some extra ultraviolet exposure, only then it can erase the data, or sometimes selective erasure is also possible. That all depends on the technique which we are going to adapt to erase the content. And now we will see the comparison of this RAM versus ROM. So RAM, as we already told, it is random access, and ROM is read only memory, and if it is read only, this RAM is also read and write, and here we have told type of access random access. Coming to ROM, it is also random access, and read and write operations can be performed here, only we can do the read, and the data can be lost in the RAM, so it is volatile in nature whereas it is non-volatile in nature, and of course this is faster and expensive, whereas obviously it is reverse of that, it is slower and also less expensive, and it's because it is going to lose the content, it needs to be refreshed after every few minutes or seconds, whereas here the data which is stored here is going to be static and need not be refreshed every time, and the size of the chip is bigger in compared to the size of the RAM for the same storage capacity, and there are different types of two types of RAM, namely the DRAM and SRAM, whereas coming to this ROM, we have so many classifications based on the technology which we are adapting for programming it and for erasing it. So this completes the discussion of read only memory. Now we will move on the discussion to secondary memory, also called as auxiliary memory. So as we know, main memory is going to be the memory which is going to be inside the cabin, and whatever the devices which are connected external to the computer cabin, that we are going to call as secondary memory devices. Okay, the secondary memory can be of any type, it can be a hard drive, okay, or it can be an USB or CDs, or it can be a flash drive or DVD. Like that we have so many variations of secondary storage devices, and all these secondary storage devices of course forms a last level in the memory hierarchy, and they are all cheaper, and also it comparatively it is slower. So if you just compare the size can be bigger. Okay, so unlike primary memory, secondary memory cannot be accessed directly by the CPU. So if at all the CPU wants to read some information from the secondary memory, first it has to be loaded to the main memory, and then only the CPU will be able to process the data. There are so many secondary memory devices using different technologies. They can either go for magnetic type of technology, where we have the banded disk, hard disk, floppy disk, and also we can have make use of this optical technology, where we use optical disk like CDs and CD-ROMs, and also we can also have magnetic tapes. So coming to the features of the secondary memory, of course the speed is slow when compared to the prime memory, but of course the size is going to be huge, and the data will not be lost because it is non-volatile in nature, it is permanently stored, and it can store large collections of type for a backup. So whenever we want to back up some multimedia content like audio signals or video signals or images or textual data or any kind of software, for that purpose we can make use of this secondary memory as a good option for for backup, and all the data stored in the secondary memory cannot be lost because it is going to be a permanent storage, and even if the power is off, we will be having the data available in the secondary memory. It has various optical and magnetic memories to store the data. Coming to the classifications of the secondary memory, as we have discussed, one is called as hard disk. The hard disk will look like this, so you will be having the storage devices inside this sealed caching, and all every computer will have large storage devices, and it will be having the permanently storing installed software, music, documentation, and other things which we need not be to be deleted, so that sort of informations can be stored in the hard disk. Then comes a floppy disk. Of course floppy disk is not nowadays recently used. In olden days we have used, the disk will look like this. Okay, there will be a notch, and this is also a kind of a secondary storage devices, and it is available in different sizes varying in inches, 8 inches,
inches, 5.5 inches, and 3.5 inches. And of course, we need the floppy drive. So inside the floppy drive, we will insert the floppy disk, and then we will the CPU can be allowed to read or write. And of course, there will be a notch in this floppy disk which can be slided here and there, so that we can also do some write protection into the floppy disk. Okay, so it is rarely used, and it is a very low memory usage, and it is old. It is used only in the. It is preferred only in the olden days. Of course, the material inside this floppy disk is made up of some plastic material with flexible magnetic coating, and it records information by making use of the magnetic principles. Then comes the CD, which is often used, and hope you all will be aware of this. It is It is an abbreviation of compact disc. Okay, the size is very much small, meager. It is easy to carry, and usually the CDs also will be used to store the audios, videos, files, and OS backup file, or any sort of information which needs to be stored and referred later. And the width of this CD also is going to vary in size based on the capacity of the data which is going to be stored. And of course, it uses laser light technology to read the information and write the content into the CD. Then coming to this type of CD, it can be CD-ROM, which is otherwise referred as compact disc read-only memory. As the name implies, these CDs can be used only to read the content from the memory, and we cannot write anything into that memory. And we have CDR, compact disc recordable. So as the name implies, it is also permitting us to record. So blank CDs could be available under this option. And as a user, we can start burning the information onto the disk. So the process of writing the information onto the disk is otherwise called as burning. For that purpose, we can make use of separate softwares available to record the program inside the CD. And the combination of the first two category, whereas we have CDRW, which is nothing but compact disk rewritable. So once it is stored, we usually use that for reading purpose. And if I want to change the content, that can also be done, provided if it is going to be bought with an option CDRW, where it is a rewritable CD. So we can keep deleting the data stored on it, and then we can rewrite with some other data which is required. Then we have the concept of DVD drive or disk, which is otherwise referred as digital video display or digital versatile disk. As the name implies, its versatility, it can handle any type of information, namely any media content. And it was developed in the late 1995 by different manufacturers. Of course, Sony, Panasonic, Toshiba, and Philips are well-known electronic companies which manufactures these DVDs. And DVDs also comes in two versions: either it is DVD-R readable or DVD rewritable, where we can erase the content and then we can rewrite. So it is going to be very much similar to that of the CDs, except that the capacity is going to be huge. So DVD recordable and DVD rewritable and erasable options are available, and we can store any of the media content whatever we are dealing with for processing and to be stored in this DVD. The storage capacity of the data, usually it will be in the range 4.7 GB to 17 GB. To that extent, the size is going to vary. And there is another concept called Blu-ray disc. It is going to be a different technology, and it is used to store large amount of data. And especially when the video is going to have some high definitions, which is going to have some extra parameters to improve the resolution, then we can make use of this Blu-ray disc. Of course, it uses laser technology. So all the informations are read and write from the disk by using the laser technology, and it can store more data with a less compact size. So that's a technology of recent day, and DVDs can provide the capacities of 28 GB space to store the data. Then comes pen drive. I think pen drive, many people will be already aware of it. We will be using this pen drive, otherwise called as USB. It is a portable device, and it is used to permanently store the data and to carry the data from one computer to another computer. Usually, it is used for transaction or transferring the files from one to another, and it does not have any movable parts to store the data. It is supposed like a kind of an integrated circuit chip. It stores the data, and we can store any amount of data. The size of this pen drive will be varying from 64 MB to 128 GB. And I think this completes a discussion of all the secondary storage devices which has different versions. And then we will just in the next session, I think we will discuss about the cache memory and the other related concepts with respect to cache memory. Thank you.